Hello, everyone, and welcome to our webinar on material flow cost accounting and the impact of sigma-fine balance within the ISO 14051 framework. Material flow cost accounting offers several benefits for the process industries, including cost reduction, environmental sustainability, enhanced resource efficiency, improved profitability, compliance with standards and regulations. In this webinar, we will cover an overview of material flow cost accounting and show how SigmaFine plays a significant role in supporting MFCA through accurate data collection, material balance calculations, loss monitoring and reporting, and process optimization. The material will be presented by Marco Lantieri, PIMSOS Industry Principal for Refining and Chemicals, and Felicia Moody, PIMSOS Industry Principal for Metals and Mining, Fertilizers, and Power. Following the presentation, they will be available for a live Q&A, so if you have any questions that come up during the webinar, kindly ask using the chat feature on the right-hand side and we will answer them at the end. We will also be making this presentation available in PDF along with the recording, which should be available in the next couple of days to all who registered. We thank you for your attention, and now I'll turn it over to Marco.
The question that gave birth to the material flow cost accounting is the following. What can enterprises do to ensure that they are economically sustainable and at the same time environmentally responsible? Material flow cost accounting approach has been incorporated and standardized in the ISO 14051-2011. ISO 14051 belongs to the same family of the more famous ISO 14001. Whilst ISO 14001 provides the requirements for the setup of an environmental management system, ISO 14051 provides a framework to make an organization understanding the potential impact of the material and energy use in its operation and on the environment as well as on the financials. MFCA is a concept originated in Germany in the late 90s, in the manufacturing industry mainly. It has seen quite a large adoption in Japan in the early 2000s, to be furtherly standardized by ISO in 2011. Although, given the origin, it has seen an historical adoption mostly on discrete and solid material flows, its adoption is increasing in liquid flows industry as well. Main achievements are an improved waste recovery, reduction in waste and material consumption, minimization of inventories, etc. MFCA becomes even more powerful when it is used in industries which has the possibility to consume recycled materials as feedstock, as the associated value of recycled material is often significantly different from raw materials, as we will see in one of the use cases that will be presented later. But how does MFCA methodology differ from traditional accounting? Well, whilst traditional accounting captures financial transactions and monetary values, MFCA captures data related to the physical flows of materials, energy, and is extended to consider the value of associated losses or waste. These are the four principles of material flow cost accounting. First of all, the flow of all materials and the energy used for each quantity center, so the envelope considering the analysis, should be traced to understand how materials are used and transformed along the whole process. So this implies the development of an appropriate flow sheet. Through MFCA, the environmental related decision-making process can be linked to financial information via the material flow model, which provides a better understanding of the real costs of material and energy, both for production but also waste generation, and results in an improved decision-making process. MFCA requires that all data to be verified at all inputs and outputs to be identified and quantified. It is recommended that all data to be converted to a common unit of measure. Using accurate and complete data is critical to identify the cause and source of any gap between inputs and outputs. And finally, real costs should be assigned to all material losses and products. When exact information is not available, the cost allocation should be as accurate and practical as possible. In MFCA, the information on costs attributed to material losses represents one of the main incentives for process improvement. Let's see the fundamental elements of MFCA. The quantity center is typically one or multiple process units. The center can be either a physical or a logical entity at which the material balance will be calculated both in physical and monetary units. One quantity center can include either a single process or multiple processes, depending on the amount of the material losses identified at the unit of production. Examples of quantity centers include points where materials are stocked or transformed, such as storages, production units, waste management, shipping and receiving points. In MFCA, all materials that goes into and leaves the quantity center should be balanced. For each quantity center, the amounts of inputs and outputs should be quantified. A material balance requires that the total amount of outputs, so of the products and material losses, to be equal to the total amount of inputs, taking into account any inventory change within the quantity center. Through MFCA, the material balance of inputs and outputs is linked to monetary units by assigning or allocating costs to all products and material losses. MFCA considers 4 types of costs, all of which are allocated to both products and material losses. So material costs, energy costs, system costs, and waste management costs. The material flow model refers to a visual representation of a process that shows all the quantity centers in which the materials are transformed, stocked, or used, as well as the flow of these materials within the system boundary. So now let's look more in detail to the classic balance for MFCA. So if the material balance is looked more closely, the classic approach given by MFCA is quite straightforward. Around a boundary that can be the full facility or a specific quantity center, you consider the raw materials in input, the generated products, and by difference, the corresponding loss or waste production. Unfortunately, there are some shortcomings with this approach. Indeed, the classic approach is not considering the uncertainties regarding the quantities both of the inputs as well as of the products. Moreover, the considered loss and waste can differ from the real accountable losses and can overestimate the unaccountable ones. As many of you probably know, these are exactly the kind of gaps that Sigma Fine is asked to close. By applying Sigma Fine balance, error is minimized and reconciled losses are optimal due to the reduction of data inaccuracy. By closing this gap, over-allocation of waste and losses is reduced, resulting in more reliable figures for MFCA analysis, supporting a continuous improvement path and cost reduction. In doing so, Sigma Fine shapes the data in the proper context to be easily aggregated with cost tables, and typically monthly aggregated and then posted to the ERP level. Now, let's introduce a couple of case studies. The first one regards a wastewater treatment of a petrochemical plant. This is a simplified flow sheet of a fence balance, and inside some quantity centers are defined. A center refers to any significant area of a process where product waste and costs are of interest. MFCA quantity centers tend to be high-level diagrams, which will not have granularity down to each tank, meter, or pump. Due to data inaccuracy, the material balance is typically not closed. Indeed, if we look at the balance around the full facility and looking at the raw data, we see that there is quite a bit of imbalance, as well as a high level of uncertainty around the data. Applying Sigma Fine balance is valuable not only to close the balance, but moreover to reduce the high uncertainty in the numbers. Here we are only showing the value in mass, but in the MFCA framework, also cash equivalents are reported. Once we apply the mass balance and the error is minimized, we can compare the reconciled figures respect to the raw data. So the imbalance has been eliminated, all the material flows have been reassessed, and as you notice, there is both a significant reduction in the uncertainties as well as in the declared waste. If we look more closely to the most relevant items regarding the waste, so the slop oil and the sludge, there has been a reduction from respectively 104 and 100 tons to 86 and 90 tons per month. And the related uncertainty has decreased from 26% to 16% or less. So before we have shown figures for the overall balance. Here instead we show the cost allocation by quantity center. As you see, the highest costs of the plant are related to the waste sludge treatment and the slop oil separation units. The significant impact of mass balance that we have seen in the previous slides have been translated in 1.8% reduction of total annual costs. Additionally, thanks to process optimization after analyzing MFCA results, further achievements were reached, including minimization of excess activated sludge through ozonization and decrease annual waste from 0.6% to 0.3%. I will leave to my colleague Felicia to carry on with the second use case.
Hello, I'm Felicia, and now I will be taking you through this use case, which is related to the recovery of rare earth metals. Here is the raw data regarding the boundaries of the plant. The flow model takes into consideration several quantity centers, which are not shown in this schema, targeting different process units. But pay attention to the overall uncertainty. It is 17% in the overall balance. Also, there are high uncertainties both on the raw materials as well as on the products and on the waste. This is really a typical situation in metals and mining. As we know, the nature of the operating environment, it's hard to have continuous and reliable data. Applying SigmaFine is valuable not only to close the balance, but moreover to improve the data quality and uncertainty associated with these numbers. Here, only the mass is shown. However, in the full implementation of MFCA, cash equivalents are typically reported. After reconciliation, not only is the imbalance eliminated, but the huge improvement in data accuracy has been achieved, thanks to the very high redundancy in the associated SigmaFine input. Let's take a look at what was achieved. Indeed, the overall uncertainty dropped from 17% to less than 1%. Waste declaration has been reduced by over 3.5%. And we have seen an allocation shift from inventory to products. Let's wrap up. From previous case, we have learned that MFCA requires mass and energy balances to manage material and energy flows within organizations, which is one of the key capabilities of SigmaFine. Moreover, as declarations are often subject to auditing and other internal or even third-party requirements, SigmaFine platform provides native auditability and data processing capabilities. Furthermore, since the need of a tight integration with other systems in the company, such as ERPs, material handling, etc., SigmaFine integration framework is ready to offer bi-directional receive and pushback balanced data. Recalling this slide, which Marco presented earlier, we have seen at the beginning of this presentation, SigmaFine can be used to perform mass and energy balance models. SigmaFine can also be used to integrate cost tables to cover raw material cost, product, waste, utilities, and even additional costs such as needed, which allows one to perform and prepare the data needed for MFCA practice. Let's look at how this data can benefit the organization. By analyzing the more accurate reconciled data, plant managers and operators can identify inefficiencies in material and energy use, both at an overall view and also at the quantity center level, leading to cost savings and environmental impact reductions. Track performances over time, enabling a continuous improvement within the organization. Being web-based, SigmaFind enables easy data sharing, visualization across the company. This slide is really for our users. It's call to action. If you're already a SigmaFind user, you probably already have in place a balanced model. By improving an existing template, you may use your current SigmaFind to cover this additional functionality of your business, which is the mass and energy flow balances as defined by MFCA. Quantity centers can be identified by assigning proper SigmaFind attributes to the assets belonging to each QC. Monetary values can either be directly associated in SigmaFind, or more often, integration between material energy cost flow is done at the ERP level through SigmaFind integration framework. SigmaFind data can be aggregated over a defined period needed to perform the MFCA, typically on a monthly basis. Data can be shared across via reports. By analyzing data over time and combining not only reconciled values, but also SigmaFind data quality indicators, users can identify opportunities of improvement in their process and monitor performances over time. This is Marco and Felicia, and we thank you for taking the time out to join us, and we are here to answer any question you would like to ask. Thank you.
Thank you.
Okay. Thank you, Marco. Thank you, Felicia. If you have any comments or questions, please feel free to add them in the chat using the chat function on the right-hand side. Let's see what we have here. Okay, first one. How do you move from an existing SigmaFind model to an MFCA model?
Hi, thanks for asking this one. This is quite interesting. As you saw in this presentation, we need to go beyond thinking about the production, and we need to consider also the utilities. So we need to go towards energy balancing on the utility side. And we also need to go even beyond utilities and to pay attention to our losses, both on the production side as well as on the utilities. So we need to think about utilities, energy consumption, and losses. That's getting the basic data ready for the, let's say, the primary unit of measure, which is in an energy or mass. The next level of, let's say, step that needs to take place is getting the costing done. We can do this either with SigmaFind integration framework, where we can pull prices from your ERP system, or we can have a simplification of some data tables, cost tables directly in SigmaFind. So we are based on templates. So we think it's a pretty small step to move from production accounting to utilities balance, and then going the next step to the MFCA calculations. Thank you.
Okay. How do you calculate the uncertainty of the overall balance?
Okay, I'll take this one.
Okay.
So the overall balance uncertainty is calculated by summing up the contribution of each uncertainty associated to each measurement. Of course, it's not an algebraic, it's just an algebraical sum. There is an error propagation rule that is applied. If you're interested in knowing the uncertainty around a certain balance point, which could be a quantity center or even the overall fence balance, you will take all the inputs and all the outputs, each measurement with its weight in terms of associated uncertainty, and then there is a rule, it's the square root of the sum of the squares of the absolute uncertainties to calculate the related uncertainty on the balance point. So it's just a matter of physics.
Okay. Next one. What are the specific advantages brought by applying SigmaFind to MFCA?
Well, as we have seen, let's say the first reason to use sigma fine in the context of MFCA is to improve the data quality of the balance itself. So if you just apply raw data which are not where an imbalance is present, the risk is that by simply applying the equation that the losses or wastes are just calculated as the difference between the inputs and the outputs, there is a risk that you are overestimating and over declaring in such wastes. And we know that also from both from an environmental but also from a financial point of view, this may have a significant impact from a costing point of view. Instead, by applying sigma fine, you are distributing the error according to the different uncertainties of each measurement point. In this way, from a mathematical point of view, you get an optimal distribution of the error and a better allocation of the waste, and when combined with the material cost, also a more accurate financial figure. This is, let's say, one of the main benefits. The second one, as Felicia was pointing out before, it's the fact that in sigma fine you can shape, you can contextualize the information, you can prepare it to be shared across your enterprise. Data can be taken both from process historians or databases. It's easily combined with your ERP system where you might have all your cost and financial figures. So there is also, from an architectural point of view, a good benefit. But okay, the first and most important, of course, is to get the best figures for the MFCA analysis.
Okay. Doesn't look like we have any other questions currently. We'll hang on here just a second to see if anything else comes in. Like to remind everybody that if you do have any questions, you can reach out to either Marco or Felicia and they'll get back to you. We will be sending out a copy of this presentation in PDF along with the recording to everybody that's registered. So if you have any other questions, you can reach out to them then. Marco, Felicia, thanks for all this information that you provided, and thanks for your time.
Thank you.
Thanks to everybody. Thanks for
joining.
Thank you.
Thank you. Goodbye.
Goodbye.
Bye.